Stop throwing money at GPT-4. This small model beat it, saving you 98% on API bills. The prevailing wisdom in AI is that bigger models are always better. But when you move into a hyper-specific domain, scale becomes an expensive distraction. We set out to challenge that notion. Our goal: could a small, open-weights model achieve domain superiority over the biggest frontier models? Our task was identifying subtle defects in complex technical documentation, a niche where generalized knowledge often fails. We chose Llama 3.8b. It was small, efficient, and crucially, it was capable of learning the language patterns unique to our documents. The secret wasn't the model size. It was the proprietary data, thousands of expertly annotated examples of our domain language and its errors. This data pipeline transformed raw documents into high-signal training examples. We weren't just feeding it text, we were teaching it the difference between acceptable noise and critical failure. And this is where the computational budget came in. We achieved maximum impact with minimal spend, keeping our compute costs under $500. We used parameter-efficient fine-tuning. Specifically, curating. This technique allows the small model to adapt its knowledge without needing massive compute power or retraining every single weight. Think of it like this: instead of rebuilding the entire library, the weights, we surgically installed a master key into the lock. The fine-tuning phase was about achieving convergence on our specific task. We tweaked the learning rate, batch size, and epochs to make every single gradient step count. The model wasn't just memorizing, it was internalizing the domain logic. It learned why a defect existed, not just that it existed. And then came the ultimate test: head-to-head competition against a generalized powerhouse like GPT-4. We presented them both the same set of novel technical documents they had never seen before. The task was to flag the most subtle architectural mismatch, a defect that requires deep, specialized domain intuition. GPT-4 relied on its vast general knowledge base. It was good, but it approached the problem from a breadth of perspectives. Our fine-tuned Llama 3 approached it with the surgical precision of a specialist. It didn't generalize, it drilled down into the specifics. And on the benchmark? Our specialized model consistently outperformed GPT-4 on factual accuracy and identifying those domain-specific nuances. The margin of error wasn't just small. It was the difference between a passing grade and a catastrophic failure in our simulated engineering scenario. It demonstrated the power of depth over breadth. When your problem is specific, generalization is a handicap. The lesson for every AI builder is this: don't assume scale automatically equals quality. Ask if the model has earned its existence in your specific domain. If your application is highly niche and your data is proprietary, the cost-benefit analysis shifts entirely. You can achieve enterprise-grade performance, and often surpass it, by leveraging the right model, not just the biggest one. So, if you're drowning in API bills trying to coerce a massive model into doing specialized work, it might be time to stop throwing the money and start focusing on the data pipeline. Curate your data. Select your model. Fine-tune efficiently. The true power isn't in the model size, it's in the depth of its domain knowledge. Want to see the exact data schema we used for this specific fine-tuning task? Check the description below. And if this resonated with your scaling strategy, hit subscribe. Let's build smarter.